Okay, so good morning, students. Now we'll see one problem solved by using the slope deflection method. Okay, so here in this case, the continuous beam is given to you, and in this continuous beam, having the supports A, B, and C, which is A support and C supports both are the fixed ends, and B support, which is intermediate support, that is hinge support. Okay, now in this case the two types of external loading have been given to you. One is a point centrally acting point load, and another is the UDL, that is uniformly distributed load, that is 20 kilonewton per meter. And here in this case, the span length for AB span it is 4 meter, and for BC it is 6 meter. And see here in this case, or in this given problem, the material properties are different, that is I and 2I. Okay, now we have to analyze this given structure by the slope deflection method. So how to solve it? Let's start. Okay, so we'll start it the step by step process. So step number 1, that is to calculate the fixed end moment. So how to calculate it? So at the time of calculating the fixed end moment, we have to assume that the beam the beam having both the ends are fixed end. That means the A and B, both the ends are, we are assuming that both the ends are fixed end, and then we have to calculate the fixed end moment, that is M bar AB and M bar BA. Now in this case, or for the span AB, which is having the centrally acting point load, so the fixed end moment formula is minus WL by 8 and plus WL by 8. Okay, that means the moment which is anti-clockwise, it should be taken as a negative, and the moment which is clockwise, it should be taken as a positive. Okay, so use this formula, that is minus WL by 8 and plus WL by 8. Just put down the values and calculate the answers of fixed end moment for the AB span. Now for this second span, that is BC. Again, we have to assume that both the ends are the fixed ends, and then calculate the fixed end moment for BC span, that is M bar BC and M bar CB. So the span having UDL, the fixed end moments, the formula is WL square by 8. Now again in this case, we have to use the sign convention, that is anti-clockwise moment should be taken as a negative and clockwise moment should be taken as a positive. So minus WL square by 12 and plus WL square by 12. So just put down the values and calculate the answers. Okay, so in this first step, we have calculated the fixed end moment. Now second step is we have to consider the displacement as an unknown here. Okay, so we have to use here the slope deflection equation. So what is the slope deflection equation? We have to calculate the slope deflection equation for each span separately. That means the span A to B. Okay, next equation for the span B to A, again the next equation for the span B to C, and reverse C to B. That means as in this problem the two span are given to you, that means we have to formulate the slope deflection equations are four equations. Okay, that means two spans are given, you have to formulate the four slope deflection equation. So let's start for the slope deflection equation. So MAB is equals to M bar AB, which is a fixed end moment, plus 2 EI upon L into bracket 2 theta A plus theta B minus 3 delta upon L. Now this is your slope deflection equation. So students, there is one hint. So there is one hint in remembering the slope deflection equation. So what is that hint? So see here in this MAB, okay, so the span is A and B, A to B. That means the first letter, it should be taken as a 2 theta A. So let's take in this bracket. That means the first letter you have to take twice of theta A, and the second letter it should be taken as a second time, that is theta B. Means whatever the sequence of your span, you have to take in the same manner that sequence in that bracket. Okay, So just put down the values in that slope deflection equations. Now m bar ab, that means the fixed end moments we had calculated in the fixed first step. So that so from that step you have to take that value, that is minus 20. Next, theta A and theta B is the rotation at the supports A and B. Okay, now see here, as the support A is a fixed support, okay, as the support A is a fixed support, there should not be any rotation. There should not be any rotation. That means the theta A should be equals to 0. Okay, why it is so? Because the A support is a fixed support, and for that, and fixed support means it should not be moved from anywhere or any point. Okay, that means that support should be fixed or rigid support. Okay, therefore the theta A is equals to 0, and similarly the delta is equals to 0. The delta value means the sinking. As the sinking is not mentioned in the given problem, therefore the delta value also should be taken as a 0. Now only one term is remaining, and that is theta b. So just put the values, minus 20 plus 2 ei upon 4, L is 4 meter into theta b. Okay, so that will be your first equation. Now second equation we have to formulate is for the B to A span, that is MBA. Okay, so same equation you have to use here, just reverse that terms in the bracket. As we are calculating the slope deflection equation for the B to A span, that is MBA, the first letter should be taken as a first term in the bracket of twice of it. That means B to E. In that term, the B is a first letter, therefore the first term in the bracket it should be of 2 theta B plus theta A minus 3 delta upon L. The whole equation should be same. Okay, so similarly the equation, in this equation again put the values and uh, give the number to it as the second equation. Now next equation is MBC. MBC is equals to same equation you have to use here, m bar BC plus twice of EI upon L into twice theta B plus theta C minus 3 delta upon L. Again in this equation, the theta C it should be taken as a 0 because C support is a fixed support, and for the fixed support the rotation is 0. Again the delta term is also 0, that means only theta B term is remaining. Now in this equation, twice EI. As I said before, the material properties for the BC span is given as a twice of EI. So the twice I it should be put here. Okay, therefore it is 2E into bracket 2I. Okay, so just formulate here, and that will be the equation 3. Now similarly for the MCB, that is reverse of the third equation, just put the values and give it number to it as a fourth equation. Now the next step is use the equilibrium condition. So what will be the equilibrium condition here? We have to use the joint equilibrium condition at the support B. Why it is so? Because the B support is intermediate support, and as well as it is connecting to the two span, that is BA and BC. That means the B is such a support that is connecting to the two span BA and BC. Okay, that means at this support B, the two moments are equating to 0. That means summation of the moment at B is equals to 0. This will be the first equilibrium condition, that is MBA plus MBC equals to 0. Okay, so MBA plus MBC, we have the values or we have the equation in the second step, and that is equation number 2 and equation number 3. So just put the values of equation number 2 and equation number 3 in the above equation. Okay, and from that equation, now in this equation you can see here ei theta b is the only one unknown, and that you have to calculate. So just resubstitute all the terms and calculate the value of ei theta b. Okay, so this is the unknown and you had calculated that. So now in the next step, and that is the last step, that is step number 4. So what is the last step? You have to use this ei theta b and substitute the value of this ei theta b in all the four equations of slope deflection, that is equation 1, equation 2, equation 3 and equation 4, and calculate that final end moments, that is MAB minus 11.43 kilonewton into meter, MBA plus 37.143 kilonewton into meter, MBC equals to minus 37.143 kilonewton into meter, MCB is equals to 71.43 kilonewton into meter. Okay, so these are the final end moments and these are the final answers. So the last term is to draw the BMD, bending moment diagram. So how to draw it? And this is the last step, that is fifth step. So in this last step, what is the actual process? So just draw overall beam, that is ABC. Now first of all you have to calculate the maximum bending moment for each span. So for AB, which is having a centrally acting point load, so maximum bending moment for that span is WL by 4. So just use that formula and calculate the answer, and that will be the 40 kilonewton into meter. That will be the maximum bending moment for the AB span. Now as it is a point load, you have to draw its shape as a triangular shape, and for the span BC, the maximum bending moment is WL square by 8. As by using this formula, calculate the answer, and that will be the 90 kilonewton into meter. As it is a UDL, therefore the semi-parabolic curve, it should be drawn here. Okay, after that you have to just resubstitute the values of which we had calculated in the previous step, that is step number 4. All these final moments should be redistributed in this final end moment. So add this support AB, MAB moment should be drawn here. At the support B, MBA moment should be drawn here, and at the support C, MCB moment should be drawn here. So for that individual values, you have to just connect that points by the straight lines and scratch the portion which is uncommon. Okay, just remember you have to scratch the portion which is uncommon here. Okay, you don't have to scratch here the common portion. Okay, which the portion which is uncommon in overall diagram, you have to scratch that portion, and that will be your final BMD. Okay, so here is the end of your problem. Thank you, students.